Hello and welcome to Rationals 3.2 Vertical Asymptotes. Okay, so we're going to continue the study of rational function graphs, and a big part of the rational function graph is what is known as the vertical asymptote. Okay, so in this slide, you can kind of see the red dashed line. I mean, we could have probably picked a better vertical asymptote, but if you're looking at the parent graph, the vertical asymptote is actually located where it presently is, where the dashed red line is. So we didn't really have a choice. We wish it could be at a better spot so that you could actually see a little better, but yeah, you can kind of see it if you look closely, but there's a red dashed line, and that is known as the vertical asymptote, and it's basically a line or a part of the graph where the curve, right, you can see the two curves, they're never going to touch that red line. Okay, and that's kind of like what the asymptote, the vertical asymptote is. It's the part of the graph where the graph is going to get super close to it, but it's never going to touch it. Okay. So in this lesson, I'm going to teach you guys how to find the location of that dashed line. And when we eventually find the location, we're going to express it using the equation for a vertical line, which is x equals a number. Yeah, so in this slide, it says x equals a, but a basically means whatever number that corresponds to the location of that dashed red line. Okay, so like I said, in this lesson, I'm going to teach you guys how to find that location based on the rational function equation that we give you. Okay, so when you get your first example here, right, you're going to see a typical equation that you're going to normally work with. It's going to say 1 over x minus 2. Okay, so you basically want to take advantage of the fact that you want to avoid 0 on the bottom of the fraction, because having a 0 on the bottom of the fraction is going to make pretty much an undefined situation. Okay, so you're going to take advantage of that knowledge, and you're going to grab the x minus 2. So let me show you what x minus 2 I'm talking about. I'm talking about this x minus 2 right here. So you're going to grab that, and you're going to set it equal to 0, just like we have here in the example. And you're going to solve for x, so you're going to add 2 on both sides, and you're going to get x equals 2. And this is what I'm going to call the VA, vertical asymptote. So I'm just going to abbreviate it VA for short. Okay? And yeah, that's all it's going to take to find the VA. You're just going to solve for whatever value of x turns the bottom of the fraction into a 0. And as you can see here, right, if you look at the graph right here, you can see that we drew a red dashed line at the location x equals 2. Okay, since it's a vertical line, we call it a VA, and it's located at an x value of 2. Okay, so this time you can kind of see it a little better because it's not overlapping the y-axis, so you can see it a little bit more pronounced, right, the red color. Okay, and then for domain, yeah, if you look at domain, which is going to be in this circle, you look at how we wrote our domain. It says x is not allowed to be equal to 2. Yeah, so basically we can have any other number out there except 2, because if I put a 2 in place of x, it's going to be put into the bottom of the fraction, which is going to make 2 minus 2, which is going to be a 0. And if I get a 0 on the bottom of the fraction is going to go undefined. Okay, so once we find our VA, we basically find our domain as well. All right, okay, so let's look at our next number, or our next example. Okay, so this time we have 2 things on the bottom of the fraction. So what does this mean? Well, we're going to have 2 VAs, because there's going to be 2 separate values of x that cause zeros to occur on the bottom of the fraction. Okay, so when we solve our first parentheses, we're going to get x equals negative 2. When we solve our second parentheses, we're going to get x equals 3. Okay, so x equals negative 2, we have a VA at that location. You can see the dashed red line on the left. Then we have another VA at x equals 3, so you see the red dashed line on the right side. And this graph, this rational function graph, has 2 VAs because it has 2 x's on the bottom, which made a situation where we had 2 separate values that could produce zeros, right? We want to try to avoid zeros. All right, so if you look at our domain looks exactly like our VAs, right? So it said we have a VA at negative 2, so we want to avoid that number. We have another VA at 3, so you want to similarly avoid that number as well, because negative 2 and 3 are going to make zeros on the bottom of the fractions. Okay, so this is what we're going to be doing to practice, yeah, how to get the vertical asymptotes. All right, so first of all, we're just going to do just like the examples. We're going to grab whatever's on the bottom. So we're going to grab that x minus 4, and we're going to set it equal to 0, and we're going to solve for x, so we're going to add 4 both sides, and we're going to get x equals 4. So that's my VA. So make sure when you write your VA, don't do like a lot of kids in the past. They just write 4. And when kids just write 4 for the VA, I'm like, that's not how you write a VA, because a VA is a line, and 4 is not how you express the location of a vertical line. Okay, to express the location of a vertical line, you got to write x equals 4. And then when you write your domain, you're going to see how it's very similar. You're going to write x colon x, but instead of writing equals 4, you're going to write not equal to 4, because that's the number we want to avoid, right? Because if I try to use 4, it's going to make a 0 on the bottom of the fraction. So for domain, I put not equal to. For VA, I put equal to. So the number stays the same, the letter stays the same. It's just that your equal sign changes in appearance. Okay? All right, so problem number 2. So let's get this bottom of the equation. Let's set it equal to the number we never ever want to see on the bottom of the fraction, which is going to be a 0, and we're going to solve for x. So this time I'm going to actually show what I'm going to do. So I'm going to subtract 3, because there's a couple of steps that it's going to lead me to get to my answer of x. I'm going to subtract 3 first, then I get 2x equals negative 3, then I'm going to divide by 2, and then I get x equals negative 3 over 2. Okay, but I'm not going to leave it like that, because I got to graph this vertical line. So I don't know how to, well, I do know how to graph negative 3 over 2, but you might not know how to do that. So you want to transform negative 3 over 2 into negative 1 and 1/2 instead. So divide 3 by 2. It goes in 1 time with 1 left over, so 1 and 1/2. And your overall number is going to be negative. Okay, so for VAs, you don't want to leave it as improper fractions, because this is an equation of a line, and it's much easier to graph an equation of a line, a vertical line in this case, with a mixed number, or you can write it as a decimal. So you can write it like this also. So you can write x equals 1.5. That's fine also. Negative 1.5 rather. So both are fine. Okay, and when you put domain, you go x colon x, and if you want to put the mixed number, you can put mixed number. If you want to put decimal, you can put decimal. It doesn't matter to me. Okay. All right, so there's number 2. Next slide. Number 3. Okay, so these are going to have 2 VAs, because it has 2 sets of parentheses with different things in each. So we're going to grab the x plus 2. We're going to set it equal to the number we never ever want to see it becoming, which is a 0. We're going to solve for x. We're going to get negative 2. So that's our first VA. Then we're going to grab our second parentheses, x minus 2. We're going to set it equal to the number we never want it to become, which is a 0. We're going to solve for x. We get x is 2. So we got 2 VAs. Okay, so here's where I'm going to get kind of picky. I don't know if your teacher is going to be picky like me, but here's what I don't want to see. So I'm going to write it the way I don't want to see on your paper. Okay, I don't want to see anybody doing this. X equals negative 2 comma 2. If I see anybody doing that, I'm not going to give you credit. Okay, because these are 2 separate vertical asymptote lines, I want to see 2 separate equations. Okay, so if your teacher's going to let you guys write this, that's fine. That's up to them. I'm not going to let you guys do this. So you need to write it how I'm going to write it right here. So let me erase this first. Let's change it back to blue, the color of the ink, and let's write x. Oops, why isn't it not writing? Oh, I left it as eraser, that's why. Okay, so x equals negative 2. Okay, I didn't want that color. I wanted blue. Come on, go to blue. Okay, now I think I got it. So x equals negative 2, and x equals 2. So I want you guys to write it as separate equations. If you don't write it as separate equations, you're not going to get full credit. Okay? For domain, you can do it all as one. You don't got to write it separately for domain. So you can write x colon x, not equal to, and not equal to the 2 numbers that we found our VAs to be. Okay? All right, so now let's look at number 4. So let's grab our first parentheses, so x plus 5, set it equal to the number we never ever want to see it become, which is 0. Solve for x, we get negative 5. Then we get our second parentheses, x minus 3, set it equal to 0, solve for x, we get 3. Okay, so make sure, like I said, I just said this, write out your 2 equations for your VAs. Don't do that lazy way of just writing comma 3. Okay, write 2 separate equations. Okay, All right, and then for your domain, now you can write it as a single, I guess, yeah, combine them together, I guess. So -5, 3. All right, okay, so that's it. Hopefully this made sense. And in the next lesson, I'll teach you more about how to graph another part of the rational function. All right, good luck on this assignment, and I'll see you in class. Bye-bye.